Collections care, which is sometimes called preventive conservation, involves any actions taken to prevent or delay the deterioration of cultural heritage. The primary goal is to identify and reduce potential hazards to heritage with thoughtful control of their surroundings. The professions most influenced by collections care include conservator-restorers, curators, collection managers, and registrars. Definition: cultural heritage face threats from a variety of sources on a daily basis, from thieves, vandals, and pests, to pollution, humidity, and temperature, to natural emergencies and physical forces, to all kinds of light. Effects stemming from these issues can be treated and sometimes reversed with interventive conservation after the damage has occurred. However, many of the sources of danger mentioned above are controllable, and others are at least predictable. Collections care strives to mitigate the occurrence of damage and deterioration through research and the implementation of procedures which enhance the safety of cultural heritage objects and collections. The areas of particular concern with regard to the sources of damage include environmental conditions, collections maintenance, museum integrated pest management, emergency response, and collections management. Environmental conditions. Environmental conditions are highly controllable in most indoor situations. They include the temperature, relative humidity, light levels present in a collection space on any given day, and contaminants. Some flexibility is naturally built into most collections when it comes to the temperature and humidity changes they can bear, allowing for conditions to vary somewhat in response to the outdoor environment of a location. Two types of light offer potential decay to cultural heritage: ultraviolet, UV, light and visual light. Light that can be perceived by the human eye, although they can be affected simultaneously by removing light sources, reducing overall intensity, or increasing the distance between a light source and an object. Best preventive practice treats these types of light separately due to their differences. Contaminants can come in many forms, including naturally occurring chemical breakdowns in certain compounds, particulate pollutants, and accidental human contamination. Protecting collections from contaminants can be as simple as creating barriers to prevent abuse or as complicated as taking preventive actions to protect an object from its own chemical breakdown. Temperature. Any storage or display situation must take into consideration the temperature at which collection permanence can be optimized, and systems should be in place that aim to meet that standard, ideally in conjunction with efficient use of energy and funds. Different materials react to temperature in different ways. For example, ceramics are vulnerable to direct heat on a mechanical level, but many organic materials are at greater risk of undergoing phase transition if the temperature becomes excessively cold. One rule of thumb applies across the board. The rate of chemical reactions is dependent upon temperature in such a way that higher temperatures reduce the activation energy and hasten chemical degradation processes. Human comfort levels must also be considered. Storage areas can often get away with slightly lower temperatures than display areas since they are not accessed as often, and it is most likely that those who do enter the space will be prepared for the conditions. In galleries, however, viewers must feel comfortable enough with the temperature to spend time there. Otherwise, the collection will simply not be viewed and lose its purpose in being on display. Relative humidity. In recent decades, it has become understood that even delicate organic materials have some elasticity in their response to relative humidity, RH, fluctuations, allowing the materials to swell or contract as necessary. This phenomenon is naturally reversible within a range of 50% plus or minus 15% Rh. Destructive chemical and mechanical processes, such as hydrolysis at high Rh and embrittlement and cross-linking at low Rh, can be held to a minimum within a similar range for a general museum collection. Moisture has strong effects on nearly all cultural heritage materials, with ceramics and glass being exceptions to these effects in most cases. Metals face the risk of corrosion as Rh increases, a risk which is enhanced by surface contaminants and emphasizes the need for proper housing. Additionally, mold growth is far more likely as humidity increases, which not only could cause allergic reactions for viewers but it also weakens the collections afflicted and attracts other pests. In contrast to this requisite for dry conditions, if the atmosphere is not humid enough, wooden objects could crack or warp, and many organic materials face embrittlement below 40% Rh. Although minor and gentle fluctuations in Rh can reasonably be withstood by most collections, quick or drastic shifts can be harmful. Anisotropic materials such as wood and ivory are especially responsive to humidity changes, and Rh issues are compounded when they are attached to inorganic materials such as a metal. The metal acts as a restraint, hindering the organic material's ability to expand and contract as needed. Thus, cultural heritage objects composed of highly responsive materials or a combination of organic and inorganic materials should ideally be in carefully controlled climates and buffered against the atmosphere by their display or storage housing. Visible light. Visual light, measured in lux of foot candles, Fc, cannot be eliminated, as it is required both to view collections in detail and to move safely in the presence of collections. Unfortunately, this means that harmful oxidation effects which visual light makes possible also cannot be eliminated, but merely reduced to the amount necessary for the task at hand. The effects of visual light began to be studied by artists and color manufacturers as early as the 18th century, but it was not until the mid-20th century that the chemical damage caused by different lighting situations was researched in depth. In recent decades, the cumulative nature of light degradation has become better understood by conservation science. Comprehensive studies began to emphasize long-term effects and allow for short-term variation in light levels depending on the specific situation. Standard viewing, viewing by the aged, complex study or treatment, and observation of low-contrast details all may have different requirements. Practical compromise between protection of cultural heritage and allowing the artifacts to fulfill their visual purpose means there is an allowance of some physical risk. Even with this flexibility, light interaction should be limited to moments when an object is on view or undergoing study, and the level of lighting should be chosen accordingly, according to museum registration methods. 5th edition. The suggested light levels for certain types of objects is as follows. The traditional recommended light level for sensitive materials, including textiles, botanical and zoological specimens, pigmented objects, works on paper, and organic materials such as feathers, furs, and skins, is no more than 50 lux or 5 Fc. Moderately sensitive materials, such as oils and acrylics on board and composite inorganic objects, should be exposed to light levels of not more than 150 lux or 15 Fc. The traditional levels recommended for the least light-sensitive materials, such as stone, ceramics, metals, and glass, are not more than 300 lux or 30 Fc. Because lighting effects are cumulative, any limit in exposure, whether in time or in intensity, prevents material degradation. A period of intense or lengthy light exposure should be balanced out with periods of low exposure. Ultraviolet UV is a form of electromagnetic radiation with higher energy than visible light. It does not contribute to the accurate viewing of collections and is ideally completely eliminated. Otherwise, materials may be weakened in any number of ways ranging from yellowing to disintegration. Organic materials, especially textiles and paper, are particularly vulnerable to UV-caused decay. Direct sunlight holds the most potential for UV damage, but certain types of artificial light bulbs may also produce these harmful rays. Various types of filters have been developed to combat UV interaction with artifacts on display, and many of them can be used in conjunction with each other to reach the optimal setting for a particular collection. Among the first employed were heavy drapes, a simple solution to apply only if an institution can provide employees to open and close the drapes at the appropriate times based on viewer access. Many filtration devices rely on materials that absorb the UV, such as acrylic films or painted wash walls. But in doing this, the materials themselves decay and the filters must be replaced. A better solution is interference filters, which can be customized for the setting of intended use to reflect light at such an angle that it cancels out harmful incoming wavelengths. If an interference filter is selected as the appropriate form of filtration, UV is eliminated completely and efficiently. Contaminants. Contaminants in a collection can pose a threat not only to the objects within the collection, but also to those individuals that come in contact with them. It is therefore necessary to ensure that all objects brought into a collection are carefully documented and researched to prevent accidental contaminations, and to create storage conditions, such as those mentioned above, to mitigate the potential for future contaminate development. Potential contaminants can take the form of gases, liquids, or solids and may therefore pollute objects and the individuals caring for them. For airborne delivery or physical contact, collections affected by contaminants will show signs of disintegration, discoloration, or corrosion, with porous materials being the most susceptible. Sulfur dioxide, SO2, nitrogen dioxide, NO2, and ozone, O3, are some of the most common types of gaseous pollutants found within collections and can result in the catalyzation of deleterious chemical reactions. The chemical reactions caused by these gases can result in the breakdown of inorganic and organic materials, or the tarnishing of metal objects. Other objects contain intrinsic elements that may begin to break down over time, causing a damaging condition known as off-gassing. The storage of construction materials and basic housekeeping within a collection area may also be a source of gaseous pollutants. The hazardous fumes given off by strong cleaning products such as bleach or ammonia can transfer to objects, causing deterioration, and construction materials such as adhesives, paints, and sealants may off-gas, resulting in additional damages. Particulate contaminants, including pollen, dust, fibers, and soot, may affix to objects after entering collection areas through poorly maintained ventilation systems. Individuals passing through a collection area may also have particulates embedded on their clothing or bodies, which can become dislodged, thereby becoming an airborne contaminant. Construction and maintenance efforts are another common cause of particulate pollution. Particulates which adhere to collection objects may cause soiling or blemishing, requiring mechanical removal and conservation efforts. These pollutants can be minimized via high-quality HVAC systems, regularly replaced filters for vents, and careful placement of objects away from high-risk areas such as designated smoking sections. construction sites, and high-traffic areas such as entryways. Human interaction with objects poses a threat of accidental contamination. Moisture and oils from human skin can cause staining of organic materials and corrosion of metals. This risk can be mitigated through implemented handling protocols such as washing hands and wearing protective gloves to minimize direct contact. Objects may also be enclosed in protective casing to further reduce direct handling when possible. Proper storage techniques, such as the use of neutral tissue or untreated cotton packed in polyethylene sheeting or acid-free corrugated cardboard, may be used to individually wrap pieces to prevent accidental contamination of objects between handling and display. Storage and display cases should be carefully evaluated for off-gassing risks, and following storage procedures such as those outlined above will all reduce the risk of contaminant damage to objects. Object handling. Every time an object is handled, it is at risk for damage. Although high standards for general housing and for packing help eliminate direct handling and decrease chances of damage due to contact, some routine activities such as cataloging and housekeeping will often require work with collection objects. To prevent accidental damage, it is important to establish guidelines for handling to be followed by all individuals in a position to come in contact with the collection. Prior to touching an object, individuals should wash their hands and determine the most appropriate handling procedures based on the medium being handled. Metal, paper, textiles, and other porous materials require the use of cotton gloves to prevent oils from human skin tarnishing, staining, or otherwise damaging the object. Glass, glazed ceramics, and other potentially slippery surfaces should be handled using latex or vinyl gloves to prevent slippage. Prior to handling an object, it is also important to 1. Take note of any structural weaknesses so that direct pressure on these areas may be avoided. 2. Any clothing or accoutrements with the potential to scratch or catch on the object should be secured. And 3. The object's weight should be considered so that additional help may be requested when handling heavier objects. It is important to examine the types of materials to be used while handling the collection. If collection objects are to be moved, the use of flatbeds, carts, dollies, or pallet lifters may be warranted, with these objects being dubbed structurally sound prior to use. Tote pans or support trays are sometimes used for smaller objects, and liners such as polyethylene foam pads, quilted furniture pads, and acid-free tissue are commonly used as an added layer of protection. When necessary, handlers may also don lab coats, safety glasses, dust masks, or respirators. Display and storage housing. Other than smart structural design, one of the major components of display and storage housing is proper selection of materials and collaboration with a mount maker in the creation of suitable display and storage mounts. Especially for long-term solutions, the materials that surround an object must not interfere negatively with the materials that compose the object. Experimentation using ODI tests is a qualitative way to determine whether specific materials undergo deleterious chemical reactions in the presence of one another. Environmental conditions as explained above are also crucial to housing decisions. Packing and transport. Proper packing techniques and materials are the best way to achieve object safety during transit. And, as with nearly every aspect of preventive conservation, these must be determined in response to the particular objects involved. An ideal shipping container not only provides a shell of protection from shock, vibration, and mishandling, It also helps insulate the interior climate from fluctuating atmospheric conditions and defend against pests. Packing mounts, protective wrapping and cushioning, packing materials, crate size and layers, and means of transport are all variables which an object handler must work into an effective strategy for safe shipment. Successful moves of the past suggest that the shipment of objects began with a complete inventory and condition survey of the objects prior to their movement. If a large number of objects are to undergo the transition, it is recommended that a smaller, representative group be sent first to reveal any improvements that can be made for the bulk of objects. All objects should be assessed to determine whether they need stabilization before shipment. It is possible that some should not travel at all due to their condition. Often journeys require several means of transport and transitions from one shipping company to another. Therefore, investigation must be done to determine the least reliable portion of the trip, and packing details should revolve around that. Many collection departments contribute to successful object movements. Conservators, registrars, collection managers, photographers, and curators should all be involved and help contribute to clear planning and communication. Throughout the process, multiple institutions are usually involved as well. The destination of the shipment must be evaluated so that the objects can be prepared adequately for transitions, including considerations for acclimatization and unpacking. Dissociation. Dissociation is considered by the Canadian Conservation Institute as the 10th agent of deterioration. Dissociation is the result of the human error in the systematic, integrated pest management. Pests pose a serious threat to cultural heritage. Whether they feed off of the composition materials or seek shelter within a collection, they can cause damage through actively dismantling or consuming objects, staining or dirtying them, weakening structures, or simply by attracting other harmful creatures. Pests that frequent collections can be grouped into 4 main categories: stored product and fabric feeders that feed on dry, organic materials, wood-destroying insects, general feeders that may damage a variety of material types, and nuisances and health hazards, which may not be as harmful to collections, but are otherwise considered undesirable or risks to human health. Commonly encountered pests from within these categories include insects, microorganisms, and rodents, but in certain locations birds, bats, lizards, and mollusks must be considered a threat as well. The approach to preventing pest infestation has changed quite a bit in the methodology employed. Where formerly fumigants and pesticides were applied directly to every collection, now more passive and less toxic means of pest management are favored. These newer techniques, termed integrated pest management, IPM, can be just as effective with careful and thorough planning. Different object materials are sensitive to different infestations, so a thorough material understanding of the artifacts to be protected and the pests resident to the area is required. Risks involving the collection building, constructive and decorative materials, and staff activities should be assessed, and a program should then be put in place which reduces these risks. The primary goal of IPM is to prevent pest infestations through careful planning. The simplest way to prevent pests from entering areas of concern is to keep the space uncluttered and sanitary. Additionally, holes or cracks in the building construction should be filled if possible, and deteriorating areas should be repaired and monitored carefully for breaches. All objects brought into the collection should be isolated for a time until it can be confirmed that no pests have traveled with the object. Regular inspections for signs of infestation should take place, and these should be well documented to track any changes in problem areas and the effectiveness of the system in place. Careful monitoring of environmental conditions within the building, such as those outlined above, can also be implemented to deter pests from entering the facility or discourage them from flourishing should they gain access. If an infestation does occur, the response must consider the safety of the cultural material involved. Individual objects can be quarantined through bagging to either contain or prevent infestation. Effective treatments include fumigation, freezing, or pesticides. Cost may be the major deciding factor, based on the infestation and the institution. Emergency precautions and response. Every type of disaster, from fires to floods to earthquakes to civil disorder, falls into the category of emergency when it comes to cultural heritage. These cannot be controlled, of course. However, they can be predicted to a certain extent based on the location of the collecting institution, and the readiness of the institution for extreme situations can be controlled. Many times if a catastrophe strikes, collections cannot be returned to their previous condition, and large numbers of objects face this risk at once, making the development of an effective risk management plan essential. Well-designed display mounts and storage housing, regulated storage space, and rehearsed drill procedures all contribute to effectively mitigating the risks associated with emergencies. Because of the interdisciplinary support such endeavors require, an additional benefit is that separate departments gain a better understanding of each other's roles and how they overlap. Collections management. The management of a cultural heritage object serves to identify the staff members responsible for care and maintenance of the collection, and establish proper management technique guidelines. Records management should take place when an object enters a collection, when it is moved or shipped, during regular collection inventories, and throughout in any conservation treatment as per established collection management policy standards. Record management of a cultural heritage object often takes place in the form of photographic documentation combined with written reports designed to provide a visual reference for future professionals, revealing the original condition and any successive states of the condition. These records are sometimes digitized and stored in computer databases using collection cataloging software. One aspect of records management designed specifically for sustaining these digitized records and documenting digital collection materials is known as digital preservation. This technique is used to reformat or duplicate an original object so as to preserve a piece of digital material for as long as possible, combining strategic planning with conservation actions. Digital preservation aims to maintain continued access to digital objects that would otherwise become obsolete. Through proper records management, the success or failure of object treatments and housing can be determined and valuable lessons can be applied to future decisions. Most importantly, if anything should happen to the object, whether through disaster or natural decay, a record of its presence and purpose will still remain. See also Wikipedia, Wiki Project Collections Care, http www.aucklandmuseum/your-museum/about-is/blog/2017/cleaning-but-not-as-you-know-it http www.aucklandmuseum-museum.com/discover/stories/lifting-the-lid-on-50-year-old-tins http www.aucklandmuseum-museum.com/discover/stories/blog/2018/message-in-aid-bottle. Further reading. Koesler, Robert J. al. Editors. 2003. Art, Biology, and Conservation. Biodeterioration of Works of Art. New York. The Metropolitan Museum of Art. ISBN 1588391,078. CS1 maint. Multiple names. Authors list. Link. CS1 maint. Extra text. Authors list. Link. Appelbaum, B. Preserve, Protect, and Defend, A Practical Guide to the Care of Collections, New York 2018. Canadian Heritage Information Network. September 30, 2011. Summary, Digital Preservation. Best Practices for Museums. Retrieved October 26, 2012. U.S. Department of the Interior. February 13, 2006. Frequently asked questions about contaminated museum collections. PDF. Retrieved October 27, 2012. American Museum of Natural History. 2005. Museum SOS. Retrieved November 2, 2012.